Okay, this is cool. Yeah. So so today our speaker is Wilfred from Cloudera. So Wilfred is both Apache Hadoop and the YuniKorn committer and PMC. So he has been driving really hard for the YuniKorn project in the past years. And we are very honored to welcome Wilfred to give us this presentation first today. And after that, we'll have about 30 to 40 minutes for Q&A and questions about YuniKorn, about resource gathering. So as we shared today, our main agenda is about YuniKorn's big milestone and the roadmap forward. So we'll talk a lot about the details for YuniKorn's latest release and about GAN scaling, etc. So Wilfred will give us more details soon. Okay. So
yeah, I'll start sharing the screen. Please let me know if it's not showing up or.
Yeah, we can see it.
Beautiful. Okay. So good morning. My name is Wilfred. Like I said before, I've been working on Yarn and YuniKorn for a while now. And over the last probably 2 years that we've been incubating in Apache, we've made a number of big steps forward. And we're coming up to a big milestone within the YuniKorn project. So we'll go in and we'll see, and we'll step through the presentation for today, small introduction, then we'll go and look at the big milestone. We'll do a little bit more of a deep dive into the gang scheduling. After that, looking at Kubernetes support and how that affects us and what we're looking at. Some preliminary view of the current performance testing that has been going on. We had some figures from release 0.8, and we've got some new figures. So we'll dive into some preliminary figures for there because we're still working our way through getting all that stuff nicely updated, and we'll publish that on the website later on. The last bit that we're going to go into is some of the future developments that we're going to do, things that we've got planned, and things that we think we need to get fixed or implement for future stuff. So what are we currently at? Apache YuniKorn incubating, 2 years up and running, releases. We've done 4 at the moment. We're getting really close to the 5th one. So let's go and have a look at that 5th release that we are working on. So the currently in progress release has been renamed to Apache YuniKorn 0.12. So we first, when we first looked at it, let's say 6 to 8 weeks ago for planning for the new release, we were thinking about making this the 1.0 release, and that would have been a huge step. When we started looking at what we were doing and where we were, we had some reservations about, should this be a 1.0 release, or do we have a couple of things that we need to fix before 1.0? And looking a bit more deep into the technical background, we said, nah, let's move this over and let's move this from a 1.0 to a 0.12 release. So we didn't change any of the release content. So whatever was tagged for 1.0 or what we thought was 1.0, we just retagged and said, this is going to be 0.12. We've got a planned release date at the moment of December for this year. So we're getting close. We are starting to look at branching, which will happen hopefully in the next week or so. And then we'll go through the release build process and the voting and all that kind of stuff. Sharon is stepping up as the release manager for this release. So it's going to be his first release after becoming a committer recently. So let's hope that that works out. From the community perspective, we've been adding a number of new committers over the last months. Chenya has just become a committer herself, Sharon and Mani. So the community is growing. The number of people contributing to the code has been growing. So please join us also if you think you can join and give us a good impact on the code. So what are we doing for 1.0? So we've moved our 1.0 release to early next year. I'll go into the technical background a little bit more while we are doing that. The main thing that is driving us is the Kubernetes dependencies and Kubernetes supported versions that we're working on. So 1.0, February, late February at the moment. Let's see if we can tag that. So what can we expect then in this release, in the 0.12 release? We've been going through a number of things over the last months, and there's a rather large number of JIRAs that we have fixed over the months. So one of the things that we're going to add is official support for Kubernetes 120 and 121. So testing has been on its way. We've moved our unit testing and our end-to-end testing from older versions to 120 and 121. So they're running on every single change that we make. And we're reasonably stable at this point in time, still finding some little things, but we'll stabilize that over the next week or week and a half, and then we can push that out. Another big change that came in is the node sorting improvement. So Craig has worked on that one, moving from a static list to a far more dynamic way of implementation, and that should help us. And that we'll look at the performance numbers, but that has got a big impact on our performance. So the first steps are being made. We'll still have some improvements that we want to make in that same area of the node sorting, but we'll see how that works out over the next releases. We've also been working on some further gang scheduling enhancements. We still are not completely happy with that, so we fixed some bugs. We're making some enhancements to that to make sure that it works in a wider range, and that you can easier have a mix of gang scheduling and other loads that are running in the clusters. We're also working on some supportability improvements. Over the last months that we've been running things, we noticed that some of the logging didn't line up, wasn't as easy to look at the logging, missing logging at certain points and in certain pieces. So there's been some changes going into that area. The other big change that we've made is that we are in 0.12 allowing you to do a full dump of the internal state of the scheduler. So instead of you having to throw through logs and see what is happening, what is assigned where, how things are assigned, we allow you to make a REST call to the REST API and say, give me the current state of the scheduler. You'll get a combination of a number of REST endpoints together with all the nodes, all the queues, all the applications and the allocations that are running on each of those things. So whatever runs on an application should be running on a specific node or assigned to a specific node. We have built that on top of some of the other support improvement that we made, and that is that we now, at a regular basis, I don't know exactly the number of seconds, but we check if there is a difference between what the applications think that is running on a node and what the node thinks that is running on that node. And if we see a discrepancy between the two, we change the health status of YuniKorn. So what we saw and why we did that was based on the fact that if there is a case that something runs on a node which is not fully tracked within YuniKorn on the applications, we can't clean that up nicely. And over time, we saw that a node could be fully utilized by unknown loads. That was due to a bug in the game scheduling, which has been fixed since then, but that gave us the impression that we were not transparent enough and we were not providing enough detail to the outside world on what was running where and how to monitor this. So we've got that the health check, and we've implemented an extension on that health check to show you that we're not in a good state and that something needs to happen at that point. So we'll keep making improvements in that area. We want to go further, but that's the first couple of steps on the supportability. The other big change that has come through is a change in the way that the shims and the core talk to each other. So we've simplified the messages in the scheduler interface by unpacking them a bit further, and that means that we now, instead of having one big message that gets sent that consists of all kinds of updates and things, we now get one message for a node, and that contains the new nodes, the updated nodes, and things like that. The same for an application or for the allocations. So instead of wrapping all these things up and having to do all kinds of analysis in the code, we now send smaller messages between the shim and the core. We also, at that same point in time, made sure that most of the messages are now bidirectional, because we need, especially for the game scheduling, we need that flexibility to send things between the core and the shim. Then something that you won't see on the outside, but that has been a big change on the inside, and that's the update of the dependency within the shim. So we are supporting multiple versions of Kubernetes, but that doesn't mean that we always build against the versions that we support. In our code, we've got the dependency on the Kubernetes code, and we've changed that dependency from 1.16 to 1.20. That caused us a number of problems because of the way that we integrate and the way that Kubernetes has progressed since 1.16. So this is one of the major changes that we need to go forward and go into the next releases. So this was a major milestone. So on top of that, we've got a number of smaller bug fixes that we have implemented. Some nil pointer exceptions that were thrown and panics that caused up until a proper cleanup for other things. So with all of this, I think at the moment, Apache YuniKorn 0.12 is running at about 100 to 120 different bug fixes that will be part of the release. So a rather large release again. Okay, so let's go into a little bit more of a deep dive on the gang scheduling. So the gang scheduling we provided in one of the last releases, and that was mainly focused on getting Spark applications running as fast as they can with a predefined set of resources. So for that, we defined a gang. We looked at a number of things that were happening and how that we can support the gangs and push as fast as we can. So we said a gang is something that the application needs, so we need to guarantee all the resources, or we need to do an all or nothing. The other thing that we try to get with the gang scheduling is we want to improve the auto scaling. So when you're running in the public cloud, you might not have all the things, all the nodes that you need to push ahead with the workload that you're creating. Instead of waiting for the resource to become available, because node spin-ups can take a long time, we want to make sure that we, as soon as we know, ask for the extra nodes and push that through. So we want a predictable performance, improved auto scaling, but we still want to be able to make sure that applications go in and out in a certain order, either FIFO or whatever you decide. So the gang scheduling focused on Spark applications in which we've got a driver and a number of workers. So normally on the Spark application, and we've got no gang scheduling, we start up a driver, and after that driver has been scheduled by YuniKorn and it's started up, then the next step is that the driver will start requesting a number of executors. How many? We don't know at that point in time, but every single pod will get created by the driver, and all these different executors will get scheduled by YuniKorn at a certain point in time. So that's a sequential step. Every single executor is its own pod. So if there's no space on the cluster and you need to spin up a node, then every single new executor will trigger that auto scaling. That means that auto scaling will be delayed until after the driver starts up and the driver has asked for all the executors that it wants to. Now, what we want to do what we really want to do is not wait and not do all these kind of things. So in the new way of doing things with the gang scheduling, we say on the driver, we say, give me 3 executors, and we pass that information on to YuniKorn. So YuniKorn will schedule the driver and the 3 executors on the system. For that, it will put in place, or it will create placeholder pods. So we've got 3 placeholder pods because we had 3 executors. Those placeholder pods will immediately trigger the scale up of the cluster and will guarantee that the resources needed for those executors are available. So if you're running within a queue that has got a limited resource definition, then as soon as the driver starts and it's asked for the executors, then all the resources for that Spark application will always be available in the queue. If you add another 2 or 3 other Spark applications, then all the resources for this first one are taken, and they will be available on when you go forward. Then after the driver really starts up and we get the real executor, the executor will get scheduled by YuniKorn, and we will replace one of the placeholders, the gang placeholders, with the real executor. So that's an automatic swap that normally happens on the same node that we're running on. But if there's some kind of reason that the executor doesn't fit on that node, which could be all kinds of predicate problems or storage that has run out in the meantime, then that can even happen on a different node in the cluster. So the executors will get scheduled, and every single time a new executor gets scheduled, it will replace one of the gang placeholders in the system. We are flexible, and part of the changes that are coming in are soft and hard gang scheduling. So what happens if the driver doesn't start up all the executors that it needs? So it says in the gang description, we want 3 executors, but it really only starts up 2 executors because of the way the data has been laid out, and it has no need for the 3rd executor. So we wait for the executors, and we wait for the timeout. If not all the placeholders are replaced, they time out, they get removed, and every single thing that happens after that will just happen as normal allocations. If the placeholders cannot be allocated within a certain point in time, let's say 5 minutes, then the driver is not going to wait, or the application is not going to wait until all the placeholders can get allocated. So that's the soft gang scheduling. It will then just say to the Spark application, go ahead, start working on things. We don't have all the guaranteed resources because maybe a node spin up has been taking a long time or something like that. But it at least means that we are not holding up the Spark application from executing. So we've got 2 modes. The soft mode will say, okay, I'm going to wait for a certain amount of time, and if I don't get all my placeholders, then I'm just going to start working and executing things. If you set up the hard executors, then you wait and you fail the application if you can't get all the resources that you need on the system. So that's an enhancement coming in 0.12, if I'm correct. Okay. So
may I ask one question regarding the gang scheduling? Can you go back 1 slide? So if I understand correctly, gang scheduling doesn't really speed up the Spark job as a whole. For example, if when I request driver and executor, and there is not enough resources in the cluster, so the gang scheduling will not able to even schedule the placeholder because there are not enough resources. So it will just hold there until.
With gang scheduling, we will wait for a certain amount of time, and if we can't get all the placeholders, we will say, okay, after a minute or so, we say, okay, we can't get all the resources in the cluster, so let's just start with the resources that we've got, and it will start scheduling the driver, and thus the executors will follow at that point in time. If you've got hard gang scheduling set up, then we will fail the application if it can't get all the driver all the resources that it needs. So there's two modes now. It used to be that it has to get everything before it will even look at the driver and move into an execution phase. With the soft gang scheduling, we wait, and if we can't get it all, we just start working with whatever we've got.
Got you. So basically, for the soft mode, we are not enforcing the Gantt schedule strategy anymore. We are fall back to no Gantt scheduling, basically, right?
Correct. Yes. Yes.
So there is no timeout in the hard gang scheduling?
In the hard gang scheduling, we also have a timer. In the soft and the hard gang scheduling, we both have the same timer. The difference is what we do when that timer goes off. In the soft gang scheduling, we say, go and work and do your work with whatever resource we have got for you. In the hard gang scheduling, we say, we couldn't get your all your resources, so we failed the application. So that's the big difference between the two. In the soft one, we go and do the work with whatever we've got. In the hard, we fail the application.
All right, thank you.
So what's the benefit of using Gantt scheduling then? What's the biggest unit benefit?
So it depends on what you're after. So normally you expect that when you set up the gang scheduling and when you run the gang scheduling, there are more than enough resources, that you've got the resources. But in the case that, for instance, you can't spin up more nodes in the cluster because you've run out of AWS budget or Azure budget, and you say, I can't spin up any more nodes in this thing, then with the soft gang scheduling, you will still get to go through and work your way through. With the hard gang scheduling, you fail. But if you're not running into these boundaries, the gang scheduling will make sure that you've got all the resources that you need for that job. So we're only making a change at the point that we cannot get all the resources. Up until that point, the gang scheduling still does all the reservations, and at this point that we are in the run, the driver is getting scheduled. None of the executors are scheduled at that point, but we've reserved the resources for the executors. And then when the driver starts up the different executors, we release the placeholders and we start up the real jobs on those nodes. So we make sure that when you start up the gang scheduling, that you get the resources that you need. If there's a case that you don't get all the resources that you need, you've got two ways of failing, a soft and a hard one. So.
Thanks, Wilfred. Can I add something here?
Yep.
Oh, okay. This is Wei, and I just want to add something for Gantt scheduling. Because the reason we introduced Gantt scheduling, I think one of the important reasons is that to avoid the starving of the applications. Imagine that you have 100 Spark jobs submitted to the cluster in the same time, and normally without Gantt scheduling, without any scheduling policy, you will see like maybe part of the first job get part of a resource, second job get another part of resource, and you will see the fragmentation of the resource being used by all these jobs instead of having the resource being efficiently used by, like, let's finish job one by one. And this is the common problem we saw on the batch scheduling. With Gantt scheduling, we're able to reserve the resources once user submits the job. So we know exactly the minimum resources required for each of the job, and we reserve the resource from the cluster for that job, and we start them one by one. So ideally, the applications will get more predictable SLA because they are able to, they have a much better chance to get a resource they need to run in the submission order. And that's the one benefit. And another benefit is the auto-scaling. I think you will cover that in your slides, right?
Yeah, so when we ask for these placeholders, those placeholders will trigger the auto-scaling already. So we don't even know the executors yet because the driver needs to start up the executors. So what we do in the with these placeholders, these are temporary pods that we create. Those temporary pods will be put into the Kubernetes system. And if there's no nodes available to run these on, the Kubernetes autoscaler will automatically pick up these pods and say, oh, to run this pod, I need to get extra resources, extra nodes in the cluster. So instead of waiting up until the point that the driver has started and the driver has asked for the executor, which then would trigger the autoscaling, the placeholder pods that we have created have already triggered the upscaling. So the node to run the executor on should be available by the time that the driver has started up and is starting to ask for the real executor.
Yeah, that makes sense. But I have one question here. So for example, when the driver will start and then the driver will request the executor, so that doesn't take very long. So for example, I start a driver and then the driver start to request executor. Usually it just takes seconds, few seconds.
That
so
depends.
now big benefits here, I don't see.
So that depends on what you do in the driver. We have seen that the drivers can take minutes to get to a state that it has got enough detail and enough information to start up the executors. It really depends on your Spark application and what you do within your Spark application. So there is no guarantee that it will be seconds. It could be far longer, but it really depends on what you do in your driver and what the driver code does for you.
And if the nodes is not there and you need to scale up, that's not seconds. You need to wait about 3, 4, 5, or even longer time, 3, 4, 5 minutes until the nodes can be scaled up.
Yeah, but that's not the benefit from gun scheduling, right?
No, that
will happen anyway.
No, actually, that's one of the benefits from gun scheduling. So with gun scheduling, we are going to we're using placeholder pods to reserve the resources. And those placeholder pods will be created once the jobs are submitted to the cluster. Let's say you submit 100 jobs. With the specification in the application, we know these 100 jobs maybe need 10,000 pods. And then we'll immediately trigger the upscaling to feed the resource for these 10,000 pods. That'll be very different than you launch one run driver, waited for requesting executors and trigger another round of auto scaling. So the auto scaling is one of the benefits we can get from gun scheduling. Does that make sense?
Not really, but I think it's fun right now. Yeah. Thank you for the answer.
Cool. Yeah. Let's continue with the talk.
So let's dive a little bit further into the Kubernetes support and the Kubernetes versions that we're looking at. So first, a little bit about unicorns. There's two things that we've got when looking at Kubernetes. We've got a dependency on Kubernetes and the versions that we support. So the dependency is the version that we use and to build on and to build with. So if we depend on a certain version, like we did with 1.16, we use the API and the code that is coming from 1.16. That's our dependency. That doesn't mean that we do not, at that point in time, support different versions. So if looking back at what we did with YuniKorn, we had a dependency of 116, but we supported 117, 118, 119, etc. So there's the two different things. One is what we build with, and the other one that is what we support YuniKorn to run in at the point in time. So for YuniKorn version 12, we are looking at supporting 119, 120, and 121. So that's the three versions that we're currently testing against and working with. It doesn't mean that we don't work with 122, but we are not running all our tests against 122. Same for 1.18. So we're trying to keep the sets limited to 3 to 4 Kubernetes version. Our dependency, we've upgraded from 116 to 120. So that means that internally, we are now building with 1.20. So that was a major shift for us. And there was a lot of changes that Kubernetes has pushed through since we were looking at Kubernetes 1.16. So it took a while. We've rejigged the code. We had to change what we did. But we're now running on 1.20. So looking forward to 1.0, because that's the next one that's coming up, we are looking at an unknown set of supported versions for Kubernetes. That might be 119, 120, 121, 122, or it might be 120 upwards. We don't know yet. We need to check what works and what won't work. We are looking at moving our dependency, our build code up to 122. So there's a rather large change that has come in with 122, which has got to do with the protobuf and the way that we talk to etc.d, and all these things affect our build process, and they've got a rather big impact on our build process. So what we're looking at is moving forward, because Kubernetes will go and move to the next releases, and again we need to keep up with those dependencies. So we are looking at moving towards 1.22 for our internal dependencies, and based on that, our supported versions will change or might not change going forward. So hopefully we can keep supporting all the versions without a problem. That said, when we look at the main cloud providers, a lot of the cloud providers are currently phasing out 1.18 and 1.19 already. So new clusters are all moving to at least 120 or even later versions. Now, the question is then again, do we need to keep on supporting the older versions? We'll see what we can do and how we can keep going and move and support as many versions as we can. So the main reason why we are moving and we need to move to 122 is that in 122, Kubernetes has deprecated a number of the APIs that we're using. So we have to move, it requires a number of code changes for us, things that we can use now, we can't use as soon as we move and make that change. And like I already said, we've got a number of protobuf and gRPC changes. These changes in Kubernetes have been in the works for the last year and a half, 2 years. They've had a number of problems upgrading and making changes. They made changes in 122, and because of that, we need to make these same changes in 122. So one of the reasons why we have pushed our 1.0 release to February and not made this 0.12 our 1.0 release was because of these changes that we've got in the dependencies. So there's a number of larger changes that we need to do in our build processes and things like that to make sure that we can move forward and keep up with Kubernetes. So based on that, we said, move 1.0 and we'll release 1.0 based on 122 for Kubernetes, and we'll have a good path forward, and we can make sure that we can support the community and Kubernetes versions going forward in time. So these will be mostly internal changes. So from the outside, there will be hardly any changes that you can see in the way that we work. The other part that comes in with 1.0 is the leveraging of the scheduler framework that has that sits inside Kubernetes. So we already had to move a number of things when we moved to Kubernetes 1.20 because of the way that predicates work and the way that the scheduling framework works. So we've made those changes, but we do see an advantage, and we see a possibility to leverage more of the scheduler framework going forward than that we've done at this point in time. So hopefully by the release for 1.0, we will have a proof of concept that will leverage that scheduler framework in more detail and give you a slightly different way of working, a better integration with the default scheduler, and more functionality to come to YuniKorn at that point in time. So the plans are not completely worked out for that yet, but we're working hard on getting that sorted, and within the next release, we should have at least a proof of concept and maybe something that's more stable that you can run in some test environments with.
Hey, Wilford, one question. So are you going to publish some kind of a design doc in the community? So how
Yes.
we are trying to leverage the framework?
Yes, so we are working currently, so the design doc around the deprecated APIs and the protobuf changes, that's just purely we're making the change on the dependency, and then we need to make those changes in the code. So that there's no real design doc for that part, but for leveraging the scheduler framework further than that we do now, because we already needed to do that for the predicates. But going forward, leveraging the scheduler framework further, we will publish a design doc. So that's in the works at this point in time. We're writing some proof of concept code, and we'll push that out as soon as we've got 0.12 figured out and branched and out there, and then we'll move with this further in this area. Yeah.
Awesome, thank you.
What is the feature in the scheduler framework other than the predicate we are looking to adopt first, or which is the biggest one?
So from the scheduler framework, we are just looking at leveraging the plugin framework further to help us make decisions on scheduling. So predicates was the main stumble point, because that needed to be done for 120. So we've done that. So that's there. But while we were doing that, we saw that we had another possibility to hand over some of the logic into the scheduler framework, that we don't have to do that anymore ourselves. And if we can do that and simplify our code, then and reduce our code base, that makes it simpler, easier for us to support things and move forward. So that's why we're looking at this, and we see some possibilities. We don't know how much we will get out of this, but we see some possibilities to provide extra functionality and the same performance that we've got now.
Thank you.
Yeah, that definitely makes sense. I think if we are able to use that, then it would be pretty much aligned with the framework for the Kubernetes, as well as it will help us improve our progress.
Correct. Correct. Yep. Okay. Then performance testing. About a year and a half ago, we did some performance testing, and we thought, okay, it's been a while. So the last time that we published some of our performance numbers, we did that based on 0.8, and all the details are found in the YuniKorn 33 Jira. But that was a one-off run. We've published the results on the website, and the run was done by Alibaba, one of the groups that work with us in the community. A lot has changed since 0.8. We didn't have gang scheduling. There was other things that we just didn't have. It was based on an older version of Kubernetes. I think at that point in time, we were building against 1.14. We're now building against 1.20. So a lot has changed on Kubernetes, on the Kubernetes side. So over the last months, we've been working on new figures. So if you want to see some more of that, the YuniKorn Jira 842 has been published, and all the efforts are tracked there. So the new results that we are working on, and we're not completely done yet, they're based on the master code. So that's a little bit after 0.11. We made some improvements in the code around metrics, around other things. So we're working on getting all that stuff done. But the code that has generated these numbers will be available as the next release for YuniKorn. So the publishing is in progress at the moment. We've only just finished some of the runs. Other runs are still being analyzed. And this time they were run by National Taichung University of Education in Taiwan. And they have done a terrific job running all these things and getting all the figures out. So hopefully before 0.12 is done, we will also have all these figures out on the website. I do have one little figure that I've pulled out of all these preliminary results. There's far more. There's a lot of information in there that we haven't analyzed, that we haven't put together yet. But at least this gives you some kind of idea. So we've looked at scheduler throughput with 20,000 pods, 50,000 pods in a 2 or a 4,000 nodes cluster. And what you see here is a run of a smaller set of pods, 20,000 pods on a 2,000 node cluster, if I'm correct. And then what you see here is the green line is the standard, the default Kubernetes release, the default scheduler. And if I'm correct, that is 120.10 or something like that. So it's a reasonably recent version. And then the red line is what we see with YuniKorn as the scheduling throughput. As you can see, YuniKorn was scheduling things far faster. The horizontal line, the seconds, we scheduling the 20,000 pods in about 80 to 100 seconds, while the default scheduler takes about 400 seconds to do the same amount of pods. So this is just one of the views. Overall, we can say that in general, we are more than 3 times faster than the default scheduler is, probably even closer to 4 times as faster. And we can even do better when we do some optimization on the predicate side of things, when we call stuff, and then factors of more than 5 were mentioned in the preliminary results. So hopefully in the next week and a half, 2 weeks, we'll have some more details. The first information on how we set up the cluster, what we ran in, and what we generated in the cluster, and which settings we need to fix to make sure that we're not held up by etc.d or something like that. They're all going to be documented. So hopefully with all this documentation and with all the information that we're going to put out there, we'll be able to run these numbers on a more regular basis to make it easier for us to do. So hopefully we'll see a nice set of numbers coming out soon. So looking at the future development, so we already mentioned some of that before, and one of the things that we're looking at, and we're looking at the planned version 1.0. We're looking at new functionality. So the Kubernetes dependency, we're moving to 122, which, as already mentioned, gives us a number of changes in the indirect dependencies that we've got, like the gRPC, the protobuf stuff. So that's going to be a lot of internal things. We're looking at admission controller enhancements. We currently deploy from within the YuniKorn scheduler image, but we're looking at making that fully standalone, and making sure that we can easier upgrade things and change things. So that's being worked on at the moment. We found some recovery stability issues in the last week and a half, 2 weeks. So we're moving in the direction of improving the recovery stability and enhancing that, so that to make sure that we can support upgrades and changes easier in combination with the admission control enhancements that we're pushing through. The last point is the scheduler framework and the integration. We're looking at a tech preview. We don't want to cause any problems in the current YuniKorn code, so we're trying to make this a separate build, so to say, based on the same code base. How we're going to deliver that, we're not sure yet. That will be part of that design document, and making sure that we can deliver the existing functionality, but also give you the possibility to build from the same set of source code a tech preview that leverages the scheduler framework further. So design documents and all that kind of stuff that needs to be worked on. That's still in the works. We're not there yet.
Where are you going, mommy?
Okay. I was given 45 minutes. I've been talking with a couple of questions for a little over 50. So from that point, I would say thank you for listening to us. We're available for questions. We can answer, we can clarify, we can go back to bits of the presentation if you say we need more information or we want more. And we're of course always available in the Slack channel, the YuniKorn Slack channel that we've got. And we've got the dev and the dev mailing list. Also, if you want to reach out or want to join us and then work with us on some of the code. So, at this point, I'll leave it at this for now. So I'll open up for questions and any further remarks from other people.
There are a few questions in the chat. Maybe we can look into that.
Let's see.
Yeah, I think one thing our for you didn't cover is the bin packing. So there's a question about how YuniKorn handles scaling down. Could you please answer that one?
Okay, bin packing, yes. So we have got different node sorting algorithm. So we've got a fair and a bin packing thing. I looked at putting that into the presentation also, but I've only got 45 minutes, 50 minutes, so I can't put everything in there because it was something that I was gonna mention. So we've got two ways of placing nodes on, placing pods on a node. So we've got the fair algorithm and we've got a bin packing algorithm. So looking at a cluster, and when a cluster auto scales, you want to make sure that all the pods, or as many of the pods as you can, are packed on the available nodes. And that if you are running for a longer amount of time, that you put nodes on, or put pods on nodes that are already being utilized. If you've got an empty node, then you really want the cluster autoscaler to remove that node to lower the cost of your run. So what we do with bin packing is we look at the node utilization and we try to fit the pod on the node that has enough space to run the pod and it has got the highest utilization. So we try to fit in everything on as small a number of nodes as possible. When you look at the fair distribution, we say, okay, I've got a set of nodes and I want to make sure that I spread my load over as many nodes as possible. So instead of putting everything on one or two nodes, if I've got 10 nodes in the cluster, then use all these 10 nodes and just spread everything out. If you're running in a private setup and you've got a Kubernetes cluster which has got a fixed set of 100 nodes, you don't care if you run your load spread over all those 100 nodes, because you pay the cost and you've got the cost for those 100 nodes anyway. If you're running in a cloud environment, then you say, I've got 5 nodes, I want to pack everything on those 5 nodes. And if you've got a burst of workload, then you add more nodes when you need to. But then when your workload goes down, you want to make sure that you only use the minimum number of nodes. So for cloud kind of setups, recommended to use the bin packing to limit the number of nodes that you're using. If you've got a fixed number of nodes in a private Kubernetes cluster kind of setup that you run on-prem, the fair distribution will give you a better performance overall because of the way that the CPU usage is spread out over things. So we currently do not have preemption in the scheduler. So there are limitations on the bin packing versus the fair. If you have burst out from 10 to 100 nodes and the long running jobs are spread out over all these 100 nodes, then it will not scale back nicely. And there's no preemption of pods to move them over to other nodes and things like that. So that's not there yet. When you focus on Spark executors and things like that, it's also not that easy because the Spark executor depends on the node storage. And if you kill an executor, that might mean that it needs to completely rerun from scratch again. So it hasn't been a focus of us for moving workloads from one node to another. So the bin packing is purely at the point of time of scheduling. It's not over the long run of the application. Does that answer the question?
Yeah, I have one question. So let's say one application is asking for 100 executors. Mm-hmm. So we'll trigger 100 placeholder as part of gang scheduling will have 100 placeholders. So let's say that an application 2 comes in and it is asking for 10 executors. And because of 100, let's say we have triggered, so we have allocated, let's say 80 or 90, and auto scaling started. And the second application, it has to wait for all the auto scaling to finish, and then only it will get the 10 placeholder pods, right? So is it possible to preempt the placeholder pod from application 1 and can be consumed by the application 2 since the requirement is less and they are available?
No. So that is currently not supported, because what we say is when you ask for those pods to come up and the application that has got the gang request, we reserve that for that specific application. And then to say, oh, something else comes in with a higher priority, or it's got a smaller demand for resources, so let's slip that one in. We don't do that. What would happen is if all those, if there's enough space in the queue for all those extra placeholder pods, we will generate the placeholders also for that second application, and we'll get both of them going at the same point in time. So there's no hard stop and say everything stops up until that first one has gone through. So there's things that you can change around state-aware scheduling, first in, first out. So there's things that you can play around with. We might not cover all the use cases, and we might need enhancements in that area further. But currently, we do not pull resources from one application and give them to the other application because of priority or anything else.
Sure. So just a continuing question. In those cases, so we need to monitor the throughput of the cluster as well. If say there is a driver who's asking for too many executors for gang scheduling, then, and if it takes some time to get those pods, then the throughput of the cluster might go down.
Correct.
Because we would be reserving the resources. Yeah, okay, fine.
Correct. And that's a problem anyway with scaling up nodes. So sometimes scaling up nodes is quick, and they're there within a minute or something like that. In other cases, scaling up a node can take 10 to 15 minutes. It depends really on the cloud provider.
Yeah.
So,
so even in I think with that is a notion, that's a function of your queue, right? If your queue has capacity, so it's only localized to your queue. So basically, if the resources are not, I mean, that's the same problem today in Yarn also, right? So it's the same problem. So okay.
So the problem is because of the placeholder, we would be just reserve the place, but we will not be getting the work done until everything is finished. In Yarn world, if something is there and you have the resources to run, you won't be wasting the CPUs, you will be consuming them.
No, in the Yarn world, there is no gang scheduling. If you don't want to use gang scheduling, then it's okay.
Yep. So in that case, if you just want to get things
of gang scheduling, right? If you don't do gang scheduling, it's okay. If you want to use gang scheduling, then you have to trade off something.
Yep. So if you just want to get things done, then you just use the normal scheduling, no gang scheduling. The driver starts up, the executors get started, and things get flowing through. What we saw is some customers generating in a batch kind of setup, generating 1,000 jobs within a minute, and then they say, we don't care if those 1,000 jobs take 6 hours to run, but we generate them from an external app, and we generate all the 1,000 jobs within a minute. So you just need to make sure that they queue up, and we want them to just execute. One finishes, the next one runs, then that's fine, but we just generate them all in a short amount of time. If you've got a more distributed kind of way of putting applications in, then you might not even want to use gang scheduling and just say, oh, I'm generating a new app every 5 minutes, and my driver takes a minute to start up, and then it will kick off the executors what it needs. You might not even want to use gang scheduling at that point in time. So it depends on your workload, what you're looking at, and what you want to do on what you use. So we've got state-aware scheduling, which means that we only start one application at a time, and then when that application is running, we start the next one. We do first in, first out, which just gets the pods out and the application through in a first in, first out kind of setup. So there's no, you can start up 10 applications at the same time. And then we've got gang scheduling. So there's all the different things, and you need to look at what you want and what fits your workload on what you're gonna use and gonna implement at that point in time.
Right. And I agree with that, because today, I mean, this is definitely a step forward from Yarn, in my opinion, because today in Yarn, customers do that gang scheduling, not in the scheduler, but outside the scheduler. And then they hold on to these containers, even they don't have the queue resources or the quota, right? So that is more dangerous than, I think, the soft and hard gang scheduling. I think this is definitely a step forward from the Yarn perspective, I feel.
Look, if there's other use cases and we need to enhance more, file a JIRA, work with us, help us improve things and add the new functionality to the system. That's why we're open source. That's why we're under Apache. We would love to work with you and get things enhanced and extended.
Well, I have another question. So do you know how long does it take after a new node fully spin up until YuniKorn detect it and then make it available for scheduling?
That's less than seconds. We're getting informed by, we're getting told by Kubernetes that the node has been scaled up and becomes available. So we're using the standard Informer framework from Kubernetes. So as soon as the information is available and gets pushed through into the Kubernetes system, we get informed. So that's the standard Kubernetes lag is there, but we're not any, we get informed at the same time as the rest of Kubernetes gets.
Okay, so if there is delay, must from the Kubernetes system.
Yes. Yep.
I see. So the YuniKorn grab those information from the Kubernetes API server or from somewhere else?
Yeah, but it's not just the Kubernetes layer that is causing the problem there, because when you spin up a new node in a cloud provider, the cloud provider first need to get that node up and running. It needs to put it in the network. It needs to get things, and then the kubelet needs to start up on that node. So even that first bit of getting the node put into the network and getting availability on the network layer and all that kind of stuff, that could take a while. And that's something that's completely in the hands of the cloud provider. That could be from seconds to minutes, or if they say, oh, we don't have, the autoscaler says, give me a node out of AWS that is an R5 large or something like that. And Kubernetes said, I don't have that, or AWS said, I don't have that node at this point in time, or there's something else going on, then it could take longer. So it's not just the Kubernetes layer, it is the cloud provider layer that does a lot of that stuff.
Gotcha. Thanks.
So I have one question, Wilfred, in terms of the scale out for the YuniKorn compared to the default scheduler for Kubernetes, right? So have you guys done some analysis in terms of the load on the etcd when we are running these performance benchmarks between these two scheduler? Is it different? Is it more in YuniKorn than the default scheduler? Is it similar load on the etcd, or we are adding more load to etcd? Do you want to little bit talk about that?
Yes, we do put some more load on, because when we push all those pods out in a short amount of time, yes, we get the same kind of changes and the same updates in a shorter amount of time. So we're pushing hard. So one of the things that we are currently working on is documenting all the changes that we are making at that level, because we did see that we needed to make changes at an etcd level at the API server to make sure that we didn't get blocked by that layer. So we are documenting those changes, and those are known things. So if you look at other blogs and other providers that have written about scaling up Kubernetes to a couple of thousand nodes, they all say there's things that you need to do. You need to make sure that you scale this up, make these changes on the configuration settings, just because you push the servers in the background pretty hard. So yes, we document what we make for the changes there, and that shows that if we don't make those changes, we just blocked on the performance of the underlying infrastructure that is there. So yes, we push pretty hard.
I want to add something here. I don't think we add more load to the API server, because we are using the standard informers to get informed whenever there's a pod added, updated, whenever there's a node added, updated. So that is the same as the default scheduler. But the node of the API server could be higher because we are scheduling faster. So which means more pods will be available, will be running in a shorter of time. So in that way, that is kind of adding more node to the masters. Just want to be clear with that.
You should see it like this: if we need to schedule 50,000 pods, we're making the same number of changes for YuniKorn as the default scheduler would do for scheduling those 50,000 pods. The fact that we do 50,000 pods in, let's say, 5 minutes, and the default scheduler does those 50,000 pods in 20 minutes, means that we are putting in that 5 minutes, we're putting a far higher load on the infrastructure underneath than what the default scheduler would do in that same 5 minutes. So overall, the number of changes that we are making and the number of things that we do is no different between the default scheduler and YuniKorn, but we do it in a far shorter amount of time, which means that we are pushing the underlying layer far harder than the default scheduler does.
So that definitely makes sense, and I totally get that, because our throughput is high in terms of YuniKorn than the default scheduler. Do we know any limits where this is the max we can support from the infrastructure layer, in order for us to figure out what is the scale for one cluster could be? Or it's...
No, we currently do not know, but at this point in time, what we've seen is that even for the standard Kubernetes scaling, people that are running the standard Kubernetes stuff, they say that getting to an 8,000 or 5,000 or an 8,000 node cluster does require a lot of work to get it to scale up to that level. There's a couple of blogs out there that talk about those kind of numbers for scaling up Kubernetes, and that requires a large amount of tweaking and configuration to get that to work. So I would assume that even for YuniKorn, we would need to do that same kind of tweaking. And at that point, it's not YuniKorn that's the bottleneck. It's the other things in the cluster that would become the bottleneck. And as long as we can say YuniKorn is not the bottleneck, we're good.
Right. So Wilfred, I think that makes sense. But the thing which I want to more come out of this conversation is, so we have so there are two notions, right? One is the batch scheduling, and then the online or stateless scheduling or stateful scheduling, right? The throughput for batch is much higher than what stateless or stateful needed. So so do you have any data or any blogs? I would love to read if you have something that stateless scheduling needs 4,000, 5,000 or 8,000 nodes, or is it batch scheduling actually? Those are the batch cluster or the stateless cluster?
No, we don't have anything around that at this point in time.
I see. Okay, so I was talking to Weiwei recently, and then Weiwei said he the Cloudera team is working on some kind of a federation layer, right, on top of YuniKorn. So would that be a way forward for us to scale out?
Yeah, so add to that. So basically on Kubernetes, we realized that we probably cannot scale up to thousands of nodes. That is not efficient in most of the environment. So instead of doing that, we can possibly having hundreds of nodes per cluster, sever them as a federation. And we have done some POC, but that's just POC. We didn't have any major work done so far, but we proved that is a solution to manage the resources more efficiently across multiple compute clusters. And you still have an overview of the resource utilization of all the clusters. So I think during the POC, we proved that is the solution. But yeah, we haven't started to really work on that yet.
I also see Yongyun Zhang put his hand up, so there's probably a question from there too.
Hi, Wilfred. Really nice to see you guys. Thank you so much for the nice presentation here. I have a ton of questions. Although I talked with Weiwei privately, but I still have a lot of questions. I'll pick a few to ask due to time limit. So first of all, actually Yarn has a capability of managing really thousands of nodes cluster fairly easily. So it's like, what's the bottleneck that applying YuniKorn in Kubernetes environment that we cannot support thousands of nodes?
So it's not as much YuniKorn that can't handle the 1,000 nodes or things like that. It is the underlying way of Kubernetes and the way that works. So Yarn is pretty lightweight. We've got the node manager up and running, and so it's built for that scale out. The Kubernetes layer does things differently. It uses etc.d, and there's a number of other things that are happening there. So that's where more of the limitations sit. Then it's not the scheduler itself that wouldn't be able to do that. It is the way that Kubernetes underneath works. So it's a different kind of a setup.
Okay. Thanks. Another question is that Yarn has using the fair scheduler, capacity scheduler with all sorts of queue configuration. Are all these? I know that preemption is currently not supported in YuniKorn, but besides that, other like scheduling policy, like max resource, minimum resource, and the max running apps, those kind of configurations, are they all supported?
Not all supported. We have a number of them there. So the resources per queue and hierarchical queues with resources set at different levels and all that kind of stuff. Yes, that's all supported. Max running apps, we haven't implemented yet. The basics and the tracking is there. So we've got all that information inside the scheduler, but we're not enforcing it just yet. So yes, there's enhancements that we can still do on those layers to add over the next releases. And like I said, if you've got one use case that you need, log the JIRA, work with us, and get it implemented.
Yeah, and we also have the customizable node sorting policy, app sorting policy, and placement rules. So those are very similar to what we have in Yarn in fair scheduler, capacity scheduler. We have min max capacity in the queue. So it's almost the K features are included in YuniKorn, but not all of them.
Yeah, I would like to add one more thing. Like for example, in Yarn, we had both I configure fair scheduler, I get that kind of set of features. Capacity scheduler has another set of features. But I think once we started with YuniKorn, I think we took those two, the best of the Yarn's capabilities from fair and capacity, and put it over here. All the fundamental pieces were definitely as part of YuniKorn. And the nuances like limit and things like that is where I think those are the extra things. But those we thought of adding use case basis, and hey, once we get the use case, let's get implemented. But we have all the right infra there, and from there, the good base is already there. Majority of the use cases are supported with that, and then we will from there we'll start and get the remaining gap addressed in an ongoing way.
Sure. Thanks. Thanks. Sorry, a final. Okay, please go ahead. I've already asked you 2 questions, but I have one more to go.
So I just wanted to check with you. You mentioned that you included both the capacity and the fair scheduling. So can you a little bit give one-liner or two-liner that what it means? So queue is capacity, and then based on that, you are doing fair scheduling within the queue. Is it something that's same?
Yes. So we can do 5.0 fair on applications within a queue. That's configurable over different, and you can combine, let's say, a fair queue and then have the sibling queue beside it running 5.0. So those things are there. We have got a maximum resources on a queue, being able to set that. So there are all these bits and pieces that you can fit together. The scheduling policy is configurable on the queue. Priority we have looked at, we haven't implemented yet. Anything like a max applications running in a queue. Yes, we thought about it. We haven't implemented yet. All the basics are there in the code already to enforce it, but we haven't implemented it. Max applications per user, all that kind of stuff. The basics are there, but we haven't seen the use case just yet. So when they come up, we'll extend and add those things extra. And then we pull things from wherever we need to get that sorted.
Yeah, I think I can add one more line. I think I understand what Mayank actually mentioned. For example, in capacity scheduler, we select the queue based on the least capacity, like a queue which is served in a least way. We try to select that queue first when we get a node heartbeat, right? But the whole architecture here is slightly different because we don't get heartbeats and everything. This is more of like a I forgot the global scheduling architecture in Yarn, what we did in the last 2 years time frame. I think we was part of that as well. So the whole scheduling, the way we do scheduling is slightly different compared to Yarn. So we don't theoretically need it to do those kind of checks and things like that. So rather we look at the queue, what is the policy, then we'll be able to work directly with that. Wilfred or Wavy, could you please correct me if I'm wrong? Maybe.
Yeah, that's correct. Yes, that's very similar to Yarn capacity schedulers, global scheduling. Yeah, that's
okay. So we do the global scheduling. That's good. I think this is also a nice feature to add. And secondly,
right,
I think it makes sense. And we have that elastic sharing also between two queues.
Yes. Just we do not have the preemption right now. So
that is what my follow-up question was. Yeah. When are we adding preemption?
Yes. So we've had it on the list, but the community is growing. So as soon as people in the community come up and help us out, we'll start working on that again. We had some basic preemption in the system. We thought about it for a while, but there's been other use cases that were more pressing, of the community thought were more important. So we focused on those. Things like gang scheduling came in and pushed out preemption. So yeah, if the use case comes up, help us out, and we'll start working on preemption again.
Yeah, I think Youngjin had one more question there.
Oh, yeah, thank you. Yes, my question is about the scheduling policy. So, you know, when if multiple applications are submitted to the same queue, and in Yarn we support different scheduling policy, dominant resource, for example, you know, I know that max running app is not currently not supported when there are too many applications submitted to the same queue, and you guys talked about the GAN scheduling is all or nothing. So how do we handle that? Make sure the applications would have their fair share to be executed. I mean, I probably need you know, really go through your detailed document, but I'm looking forward to the publish of your document. But if you could, could give a quick.
We've got two layers. So first we sort queues based on what's there, and we do that based on whatever pending or demand of resources we've got. And then within a queue, we can sort based on fair, which means that we look at the amount of pending resources that are there on the application, and then we distribute that fairly over all the applications that are there. We can also say, no, it is first in, first out. So whatever is the oldest application that has got a demand, if we've got space, then that one gets it. We can do state aware, which means that we still do a first in, first out, but we only allow one new application to start up at a certain point in time. So we limit the number of new applications that we consider. So we've got those possibilities, and you can set that up per queue, and then over the queues, we do it fairly.
Yeah, that's why we have the app sorting policy configurable.
Correct.
Right now we have FIFO and FIRE. So FIRE is what we're saying, where we can balance the resource utilization between these apps. But with GAN scheduling, we actually use FIFO, so that we have preference to allocate resources for the jobs that submitted earlier. And we can even extend this, right? We can write another policy, which we were discussing this yesterday. Like we ordered the application based on priority. So that's fairly easy to do based on the framework we already have. So you have flexibility that to add anything you want based on these policies.
That's very cool. Thank you.
Cool.
Another question. Sorry. It seems like you guys mentioned you still have a implementation to limit the number of active applications. Does that correspond to the max running app? Because previously you said the max running app is not really supported.
Right. Yeah, it looks like you're really like the max app configuration. So we didn't support that because we feel like it is not very easy thing to configure, because you don't know how many resources you will have in the queue. You will not have it's not very easy to control the size of the queue, the amount of the applications. So we don't want to give a number. So instead of doing that, we introduce a state aware policy, which is limiting the number of active applications in the queue, which is a very simple, but it's actually can help to avoid the risk conditions when people are submitting a lot of applications concurrently.
But the limiting number of active applications itself sounds the max running app.
No, there's a slight difference between the two things. Max running applications would be the overall running number of applications in the queue. What we do with the state aware, we do not care how many applications are running in that queue, but when we start looking at the non-running applications, the new ones that are in the queue, with state aware, we only consider one of them and we get that one into a running state. So we do not limit, that would happen if I've got a queue, I submit an application in the queue and I've got state aware, that new application will be looked at and will be moved into a running state. If I've got 10 applications in that queue and I submit a new one, then I would just look again at that one application. That can grow up until hundreds or thousands of applications in that one queue. If I would look at a max running applications, then I would say I've got max running applications set on the queue of 50 and I submit the 51st application. I do not look at that 51st application at all because I've got a maximum of 50. In the state aware case, I have got 50 running, I submit new one, I will look at that one application that is not running and I'll work with that. If I've got 10 new applications sitting in the queue with state aware, I only look at the first one that is there. So it's a slightly different thing. It's one looking at the overall number, and the other one is the one that I'm going to move from a new state into a running state.
Okay, thanks. Thanks
Yeah,
for,
yeah, but again, if you want to limit number of applications, that's very easy to add, and you can use that with fair sorting policy. That can just work like yarn.
Yep, not a problem.
Great, thanks.
We've come up to 1 o'clock my time, so that's the end of the meeting today.
Yeah. So thank you so much, yeah, Wilfred.
Leave it at this. I'll hand off to Chenya. But if there's more that we need to do this more often, we can do this more often. That's not a problem. Especially going forward, we can set up more meetings like this. So
yeah,
I'll hand over back to you.
This is very useful. We definitely have few asks. Maybe we should follow up offline with you guys. How to start working together on that one.
Cool. Okay. Thanks a lot, Wilfred. Yeah. And meanwhile, we also have bi-weekly community meetings. I share the link in our chat box. So feel free to join us. We can discuss more topics there as well, every 2 weeks. And for the meetup, we plan to schedule one every quarter. So hope to see you all in the next one. Okay. So thanks again, Wilfred, for the presentation and everyone here today. Okay.
Thanks
Thank
a
you
lot.
all so much.
Yeah, thank you. Bye.
Bye.
Thanks.